We'll quickly move along to the next presenter, Dr. Justus Masa, if you'll join us. Just a few things, I guess, about Dr. Justus. He's an accomplished academician with an electrochemistry PhD from the Royal University, and he's written and done a lot of research about enhancing energy from renewable sources. Dr. Masa is also a member of the Technical Working Group of Mineral Value Addition. So welcome, Dr. Justus. The floor is yours now.
Yes, good afternoon, dear delegates, and it's my pleasure again to present before you. I thank the Chamber for Mines and Petroleum for giving me the opportunity to speak before you once again. I'm going to speak to you about mineral value addition to salt. In Uganda for so long, we looked at salt as table salt. But the value for table salt is at most 10% of the commercial value that you can get from salt. But before I speak about the industry that I want to speak about this afternoon, the chlor-alkali industry, allow me to maybe give you a little bit of my research background, where I'm coming from. I am an electrochemist, and in electrochemistry what we do, we manipulate chemical reactions to get electricity out of them, or we use electricity to run chemical reactions. A good example of how we manipulate chemical reactions to get electricity out of them is in batteries. The car battery that you use for starting your car, in all the portable devices that you are carrying, the electronics, there we have stored chemicals which provide us with electricity. Now the opposite of that is that we run electricity through chemicals to achieve some chemical transformations. Now I lead a research group, and the focus of my research group is on a theme we call electrocatalysis and energy conversion. Our goal is to couple harnessing of renewable energies with advanced systems for electrochemical energy storage and conversion so that we can maximize the amount of energy that we get from these renewable sources, for example, the sun or the wind. Now, if you look at this scheme here, what we call power to X, you can imagine that you have, how do I use the laser pointer? Not possible? Does it work? Sorry. Now, power to X means that when you're producing excess electricity, like it happens in many countries, we are not yet having this luxury. When you produce excess electricity, you can store this by converting it to other materials, chemicals. Now, in our case, our idea is to convert this electricity into hydrogen as a potable energy chemical by splitting water. When you form this hydrogen, you can then store it in cylinders and later use it in a device we call a fuel cell to recover this energy. Now, as I assume that you are aware, when you're using your solar panel at home, you capture the energy and store it in a battery. So you cannot get more energy than your battery allows you to do. In this system like this, you can generate as much hydrogen so long as the solar energy continues to shine. So you can enhance, therefore, how much energy you capture from the sun. Now, when you have this hydrogen fuel, you can use it as a fuel, or you can use it as a commodity chemical. You can transform it. For example, you take nitrogen for free from the air, you form ammonia, then you have the fertilizer industry, and when you have ammonia, then you have access to a classified chemical industry which is leading you to explosives. So there's very rich chemistry here that one can exploit in these devices. Now, the other devices that we try to develop are what we call the batteries of the future. At the moment, I can bet if you open all your smartphones, you'll find inside there a lithium-ion battery. That's the state-of-the-art battery. But what we're trying to work on is even a better battery where you can store a lot of energy in a much smaller volume. So now we have done cutting-edge research in these areas, and because of that, we've been given some flowers. There I have some flowers for making one of the best inventions at Royal University Bochum in 2010. This work is patented, we have a world patent for it, US patent, and it was bought by Biomaterials, who now own it. Now in 2015, we won another patent also in line with this work. It's also patented, and it also won the best invention at the university 2015. And recently, again, I had news that one of our recent patents has been selected again to be among the best ones. But the hallmark of my scientific achievements is seen here. Now, there's a program run by the African Institute for Mathematical Sciences called the Next Einstein Forum Fellowship. The goal of the fellowship is to try to identify Africa's most outstanding researchers, recognize them, try to network them, give them publicity, and if possible, give them some form of support so that maybe the next Einstein of this world can be discovered here in Africa, so that we can awaken the African genius. Now, there you see me somewhere. This is a point, I'm not familiar with how it works. Now, this is the only program that I know so far, which is ambitious and tries really to motivate Africans to try to use their brain if we're dreaming about what we call a knowledge-based economies. We have to invest in the brain, in the people, and this is a program which really tries to bring this kind of inspiration. Now, next year we shall have a meeting in Kigali at what we call the Global Gathering, where President Kagame will be the chief host, and he will present us with the medals to recognize our contribution. Now, for your information, they look for Africans wherever they are. They don't confine to Africa. They look for you wherever you are. If you meet the standards, then you are recognized for that. Now, 5 years ago, very early in the morning, at around 3 a.m., I was challenged with a difficult thought. I found myself asking myself, what's my worth as a chemist? To my country, maybe to the world. But of course, being a chemist in Germany is just a drop in the ocean. It's worthless. But I thought about Uganda, and I was thinking in the sense of an electrochemist. What can I, as an electrochemist, contribute to drive our economy or to bring about industrialization? So I remembered my geography. I'd never been to Lake Katre, but I remember that we have a salt lake in Katre, which was, once they tried to exploit it for producing salt, the factory analyst, unfortunately, did not take off. It is dilapidated. It's what you see in the background there. I visited it in 2015. There you see a salt miner on the left, and you see some rock salt on the right. Now, essentially, when you process salt and you produce table salt, you get at most 10% of the value of salt. So you eat 90% of it. You just lose it in your stomach, into the food chain. Now, these folks here at Lake Katre sell this salt at a giveaway price. So we have been losing a resource, which is actually the raw material for the biggest chemical industry you can imagine to have. So when I thought about this idea, then I was motivated to come to the Minerals Conference in the previous time, and I presented about this industry. We've tried to make some efforts to make sure that we get somewhere, maybe get investors or to exploit this resource. Now what? The chlor-alkali industry feeds on brine, which is salt, electricity, and water. These are the only three ingredients that you put in there. When you put in these ingredients, you get out hydrogen, you get out chlorine, and you get out caustic. Now, caustic and chlorine are two of the 10 most massively used chemicals in the world. And chlorine actually is a key player in the petrochemicals industry. It is used to produce in hundreds of products from it. One of the chief products that you can get from it is polyvinyl chloride, an engineering plastic which we also use as conduits for water and so forth. So it is a huge, huge, massive industry, the petrochemicals industry. The caustic is used also for so many things, making things like soap. For your information, when you extract oil from the ground, and you want to use mineral impurities, you do what we call caustic washing, and here you use massive amounts of caustic to clean the crude oil before you feed it into a refinery. Now, hydrogen can be used for so many things: ammonia, fertilizers, explosives, if you like, fuel cells, oils, and so forth. It forms what we call an allied industry, if you like, because each of these leads to a chain industry. Now, let me show you the chlorine tree, for example. So this is the chlorine tree. It's boring to count how many products you get out of this. So you can get from it elemental chlorine, which we use for disinfecting water, plus many other uses. If you think about, for example, the paint industry, one of the most bulky materials in paint is titanium oxide. You get it via conversion via titanium chloride, which I cannot see properly over there. But chlorine is a gateway to a multiplicity of industries as far as you can get. Now, caustic also leads you to a wide range, is used to run many other industries, organics, miscellaneous. The paper and pulp industry is a big user of caustic. The aluminum industry, for every 1 ton of aluminum that you produce, you need 100 kilograms of caustic. In water treatment and many other industries. So these are massive, massive industries. Now, in my role as a member of the technical working group in the mineral value addition, the salt cluster, we came up with a few recommendations. We were tasked to try to find investors. The problem when you go to serious investors, they want baseline information. How much quantities do you have? What is the size of the market? What is this? So we don't have feasibility studies done on this to establish what's the size of the market, what products shall we focus on. So the recommendation was that we need to urgently find means of doing these baseline, these feasibility studies so that we can maybe find a serious investor who would invest in this industry. Now, on the sidelines, I've been doing some things in the background. When I visited Lake Katra, I took some salt with me. I did some analysis in Germany. Now, we discovered that the salt is basically very good salt, very few impurities, but it had one surprising impurity, neodymium. Neodymium is a rare earth. It is used in making supermagnets, in cryocoolers, going down to very low temperatures, and in making lasers. So this is what we observed. So this can be easily removed and we have very clean salt. Now, I tasked my students in Chambogo, where I come every semester to give some lectures. If you have been to Lake Katre, the salt has a very awful smell because of hydrogen sulfide. So we wanted to remove this bad smell from salt. Maybe we can add value, maybe even to these local miners. So we succeeded to develop a system where we can remove this sulfur. So we can remove all the sulfur completely. Now, that means with this, we can develop a system where we try to clean our salt, remove the sulfur, and the local miners can already maybe use our invention, which we shall actually apply for intellectual property to protect it, because it was not given for free. Then maybe in the future, if someone wants to use this, hopefully we can also get some royalties for our contribution in that. So just by our local knowledge here, we are able maybe to devise systems where we can already begin to add value using our students and our brain. Now, when I conclude here, in my perspective, we have been having this salt for so many years, losing the value. So what you see that you need knowledge rather than a resource. So knowledge is much more worthy than resources. If you look at countries like South Korea, Israel, Japan, these are resource-poor countries. They are knowledge-based economies. So when you go to South Korea, they don't have petroleum, but they run some of the biggest oil refineries in the world. So as we think about looking for these minerals and exploring to discover more, I think we need alongside to invest in the young people so that we can extract the best out of them, so that they don't have to go outside of Africa, like I had to go to Germany in order for Africa to recognize you, but that we can catch them while they are here, see the potential in them, nurture them, develop them, and they will really contribute to putting Africa in general on the track that we need to see. And again, this is now, we have to liberate ourselves. In my perspective, Africa has for so long been used as a consumer market. And when you're a market, if I'm selling you my goods, I don't want you the next time to be a competitor. So we have to liberate ourselves to know that we really have to reject the notion of Africa being a consumer market, but a market where we also produce and compete. I appreciate very much your attention.
Thank you. Thank you, Dr. Justus, for that inspiring presentation.